Also, I received a copy of Muzzle Blast from July of 1944, and it was A.O. Needner, was the gunmaker's name. Yeah. Mm-hmm. He had an article in there on barrel harmonics and warpings. And those boogers had the same problem then that we got today, or we got the problem that they had. They didn't produce the volumes that we do today of barrels, and they had the ability to work a piece of steel. Difference of steel and, and iron. And they had the ability to lay them on the shelf and let them age. And a barrel that ages will have different harmonics, or that piece of steel that's going to be a barrel will have different characteristics than a green piece of steel. When we're making a barrel, and again it's 12L, and we can't get American steel anymore. That particular piece of steel was made in Argentina, even though it comes in an American company. That was once a mainstay of the industry in this country. They come in and, well, whatever diameters you want, in our case, inch and an eighth, inch and a quarter, and they're 12 to 20 foot long in stock. We cut everything at 45 inches. Well, not only is that barrel blank not round, because it's pulled through a die to form it, it's not straight. We've had barrel blanks at 45 inches that were out as much as 80 thousandths. My machine, I've got an old Pratt & Whitney new in 1943. It's 5 years older than my old lady in a hell of a lot better shape. But if you have a piece of steel 45 inches long that is out more than 15 thousandths, now remember, a human hair, if I had any, that would be about 4 widths of a hair. If it's out more than that, the harmonics that is set up during the machining is so great it'll sound like a helicopter. You cannot spin that booger that fast. Well, I'm spinning 3,000 RPMs and pushing the drill just over 2 inches a minute at 500 pounds oil. What we have to do is run a steady rest bearing to be able to control the centrifugal whip. Now, the gun drills that we use today were invented in 1849 by Remington, and they've changed nothing except for the materials from which we now make them, and they're carbide. The angles of the grind, the release, is identical to 1849. That drill, if sharpened properly, is going to go in a straight line. However, if you're drilling a bar that is being whipped, that's centrifugal force, you're drilling a straight hole in a crooked bar. When that machine stops, the centrifugal thing stops, and now you have got the most beautiful curve inside that barrel you've ever seen. Now, the old timers apparently had like problems, but not due to centrifugal force, because they didn't do it in that method. But they could straighten by using a wire, whatever. They could actually straighten that hole out. So at that time, you got to wonder, can you drill it, ream it, rifle it, and then shape it? Well, we can, because we're stress relieving the steel. If that steel isn't stress relieved, if you drill that hole and ream it, the hole is round, almost round. There's nothing really round in that gun barrel. And you straighten it, there's an egg shape in there. So how do you determine if the booger is straight? Well, there's concentric rings in a shiny hole that you can use for a gauge. And once your eye's trained to look at that, you're going to find, if they're straight, you're going to find a little wetty yellow black rings spaced throughout that hole. If you can line all those up, and all the lights passing side to side in equal lengths of light, that hole is straight. If you see an egg, it's crooked right there. For whatever reason that the machining happened, that thing's crooked. If the barrel has to be straight, then one has to drill the hole, straighten it, shape the outside, and straighten it, and then you can ream and rifle. However, if we give that barrel all-timers up front, then it will, in most cases, lay in a straight line even after all the machining processes. Now, if we go through there and make a swamp barrel that's made by arching the tube, by holding it on centers and pushing a wedge under it to arch the barrel, the cutter's running in a straight line. When it got to the hill, it just plowed it off. Well, when you take the wedge out, you're going to have a low spot. Well, you're going to do that 8 times, of course. You're going to do flat 1, flat 4, so and so, because you got to work 180 all the way around this thing. But if that piece of steel does not lay straight, that hole is straight. Now, on taking a memory, again, these barrel blanks come in crooked. Yes, excuse me. We can straighten that barrel blank before we drill that hole, but if the steel is not normalized after the straightening, when that barrel gets hot, it will go back to its memory. You hear a varmint hunter with a 22-250 say, I got a 2-shooter. He's got a problem. When that barrel gets hot, it remembered where it came from and it's bent. When it cools off, like bimetal, it'll straighten back out. That's a big problem in one of these boogers right here. If you've got an ambient temperature of like 90 degrees, then you shoot it 20, 30 times, and it really gets hot, the barrel is going to elongate, and it's going to take a memory, if the memory has not been taken away by stress relief.
How do you tell them how to stress relief? How that's done?
Well, I can do it the modern way. The question was from Mark is how do we stress relieve? When I called the engineers at the steel mill and told them the problems I was having, and what am I going to do about it? He said, well, you're going to have an oven, and you're going to have to run this thing at 1150 degrees for 3 hours after it ramped up 2 hours to temperature, and then it's got to go back to ambient over about a 2.5 day period. So it's in an oven quite a long time. Well, we did that, but now remember, it's a leaded product, and the barrel blank would scale. In fact, when you take it to the straightening device, the patina would actually just leap off of it, just like an eggshell, and it just lay on the floor. I said, hell, I can't live with that. Pretty much.
Your charcoal blue.
Very, very much like that. You can't live with that. Call the engineers back up. Said, all right, reduce it to 950 degrees, ramp up in 3 hours, hold for 3 hours, dwell it's called, and then go back to ambient. All right, we still got a patina, but it was almost as if it were charcoal blued, if you will. It's a little more dull than that, and that did solve the problem. The handicap with it, it's leaching lead into the atmosphere. So you have to do it in a period of time that you're not going to be in the shop, or you're going to have some bad problems with this stuff. And but now on the straightening, if that barrel has not been stress relieved, and it's out 20 thousandths, we may, back to what you said, Bob, we may have to bend that barrel over 2 to 2.5 inches in the opposite direction because of spring back to get it to stop where you want the dimension to be. After it's being heat treated, and that spring tension, we're using a 100-year-old 30-ton wheel press. Got a big Acme thread, must be 4 inches. You can make a pretzel out of that piece of steel, and you turn it loose too quick, it'll hit you between the eyes. It's like a dad burn spring. Well, that's not much fun. But after it's been stress relieved, you may take it only 3/8 to 1/2 inch off the center line, and it spring back will come to the dimension that you're looking for. So this stuff is really alive, and we have to play with the chemistry that's in there. We have to play with what it's going to give us. And each batch, even though the chemistry is 12L14, no two batches drill the same. You get in a brand new reamer, you have to relearn the speed, feed, temperature, and all that. Now, on drilling oil, which is about $10 a gallon now, our machine holds $1,000 worth of it, you have to keep that oil cool. Because again, when you start working with friction inside a hole, a deep hole is a unique discipline. It's not a difficult discipline, but it's different from any other machine shop type operation. But the oil cannot get above 115 degrees. But the hydraulic pumps will scream if you're down around 65. So we got to go down the hole. Well, when you're drilling 2 inches a minute, and especially at 50 or bigger, the oil will go from like 65 to that 115 in only 2 barrels. So that means you're shut down for the day. I happen to live in the hills. I've got a stream or a waterfall about 500 feet from my building. So I ran an 1.5 inch plastic line around the mountain, put me in 2 liquor stills, and go on the surplus bypass side of my pump it out through those liquor stills, through the coils, through that cold water, and then bring it back to the machine. And now it'll work till I want to go home.
Whoa. comments I would like to make about that, going back to the old ones. When you forge weld a barrel, one of the worst things that you're fighting all the time, you're bringing that flat bar up and forging it. Sometimes, because you're right-handed, you'll start to get that to spiral. And then when you bore it, you can have a wind. It's the hardest thing in the world to straighten, is a wind in that bore from front to back. So you have to really strive to keep working to make sure that that's straight as you weld it. And then you can heat it and put a wrench on the end and spin it back as you're going along if it starts to. But right-handed people will have, and left-handed people will have the worst time hammering something straight. You would think you could do it, but it's really tough.
You mean the hammer welded seam itself?
Yeah, that'll start spiraling, and then when your bits, you're naturally not going to get that the same wall thickness in forge welding it. You try to, but then your bits will spiral around, and that is the worst thing in the world, to try to look through there and use it, a hammer or whatever, to try to straighten it. A fellow, and the answer to this, if you want reliable shooting, is to don't go with that light barrel. And so that's why they're shooting these big monsters up here. A guy in 1810 in Abington, Virginia, who's a militia captain, he's not a gunsmith. He received his rifles from the governor, and he wrote back and said the barrels were too light. And he said, when shot often, she will play her bullets. So he knew about it heating up and changing. This is 1810. And so he said a rifle barrel ought to be a 1/4 inch thick from the bottom of the furrow to the exterior. And out there they make these 12 and 14 pound rifles in that region and used to carrying them. But his rifles were made further up the Shenandoah Valley, and the barrel was too light. He also said that the lock was too big. They had asked for it to be 5.5 inches long and 1 inch broad. And he said the lock was too big, that smaller locks fire faster and don't weaken the stock as much. So he's a rifleman, not a gunsmith, but he knows his stuff about it. And that's in 1810. So the British were experimenting with making those smaller locks because of the quick throw on the flintlocks. And it's not just that the guys in London who were experimenting with it know about it. Average people knew about it that used these guns at that time.
Well, lightweight rifles, even modern guns, the lighter the rifle, the better the trigger has to be. If your knuckles turn white when you're trying to squeeze the trigger, things are going to happen. A heavy gun, of course, isn't as susceptible to that. But on a lock, especially the early locks, and they were large, and the parts are heavy. Well, it takes a lot of force to get a heavy object moving. It also takes a lot of force to stop that heavy object. In this case, we're talking about the hammer and a prism. Generally, lighter locks are smaller locks. Generally, if the geometry is there, they're going to be the faster locks, because the light hammer will move faster. The prism will move faster, but it'll also stop faster, and it won't shake the gun as heavy. So that brings us to the topic. Well, there was a hell of a lot of old big guns, and they worked. They did, but their springs were matched. You can have a heavy spring inside and out, and the lock will work beautifully, medium or light. But you mismatch those combinations, and it upsets time and motion.
And I would add that big old lock with the long throw might be slower, but it will go off more often, and that sometimes is what you want. That speed isn't any good if it goes plump. And so in testing those flintlocks, I don't know how many of you saw the footage that Gary Broomfield did with the, I've forgotten the rate of the photographs, but you could actually see the individual spark that ignites the powder.
4,000 frames, I think.
Excuse me?
4,000 frames, I think.
4,000 frames per
Second.
4,000 frames per second. And the thing that absolutely totally surprised everyone I know in the flintlock field, the theory had always been to put the touch hole centered by the top of the lock. so the top of the pan, so that when you fill it with powder, the powder burns across the top and goes to the touch hole. Well, in the 18th century and 17th century, the Spanish put the thing at the bottom of the pan. I always thought they were kind of weird. Well, in that magnification, that spark goes into the powder like a shot into sand, and it goes down the bottom before it ignites it. So it ignites at the bottom of the pan, not at the top. And so the Spanish knew that, I guess, and we're doing those so that the shortest distance, so you can see it erupting from underneath. And I would have never dreamed that was going on. But when you slow it down to that, you can really see what that spark is doing. And as soon as that flint came in contact with the steel, it starts throwing, the sparks go ahead of the flint. And like some people say, that solder lock doesn't put the sparks in the pan. The tests on that solder lock, they start hitting on one side of the pan, and the shower goes progressively right across as it's being created going down. But the sparks take the energy from the cock and the spring, and they are propelled ahead. And sometimes the steel is rebounding so much it naps the flint. It'll come all the way back and nap the flint when it's at rest. So there's a lot, talking about vibrations, that steel is going back and forth in those shots.
Okay, so where do you recommend to put the touch hole at then now?
I put it below the top of the pan because that's where the ignition
So you
starts.
believe blow down a little ways?
Yes. I don't like it. Like the Spanish, sometimes they notch the bottom of the pan. And a lot of, if you make a rifle by traditional means, the barrel is proof tested. And when you stock it up, you have to work with the current location of the touch hole. Whereas if you're buying a modern barrel and you presume it doesn't need proof testing, you can locate it where you want. But remember, the old guys had to proof test it, and the touch hole is already in there.
I don't know.
If they're a little off, yes.
My experience early on when I was building guns, and I put a touch hole too low, it was slow. If it was too low or too high, you could have ignition problems. And
You've seen
just
that
what I've
footage,
seen.
haven't you?
Oh, hell, of course I have.
I mean, it's not just one lock; it's a whole series.
I don't doubt that, Wallace. I'm just saying, in practical experience, when I've seen a touch hole too low, the gun has fired slow.
Okay, then how about front to back?
Well,
front to back.
I guess I haven't seen many that were off front to back that I was aware of, that I was able to shoot or saw a shot. But I don't see any advantage putting it anywhere but in the center, front to back. I don't know about up or down, except the limited experience of some of the very first ones I built and didn't get it quite right. But Larry?
Mark, in your experience with it going off slow, are we certain that we're igniting that thing with the pan powder away from the touch hole, or do we know for sure?
Well, I think that does make, I don't know really. I think it makes a difference. Now, I don't think, basically when I've shot them, any gun, I try to keep the powder away from the touch hole a little bit.
I can tell you it makes a big difference whether it's over on the hole or whether it's away from the hole.
That's my experience. Now, I don't know what you've found, Wallace, with yours. You certainly have shot an awful lot.
I usually fill the pan up because I want it to go off.
Well, fill it up. Yeah. Now, wait a minute. Don't just run off on that.
If you fill it up, it's all the way over against the barrel.
Well, you could put an awful lot of powder in there without actually just mounting it up and putting it in.
Yeah, I don't want to crush it.
I'm not talking about sweeping it off to the end of the pan. Come on, let's get realistic.
I usually fill the pan pretty liberally.
Oh yeah, so am I.
And sometimes if it's successive shots, you got other things like fouling dropping off the flint that got in there that you didn't see. And that showed a lot of that. You'd see this big slab fall off the flint. And, your next shot, you may have some of that blasted into into the, still in the touch hole, and depends on whether your powder's burning wet or dry, humidity and so forth. You don't have a lot of competition.
Yeah. Maybe hard to hear.
Well, if black powder is an explosive as compared to a propellant like modern, it must have a pressure per time, but is the burning and the flame what ignites the barrel, or is the extreme heat generated that sets off the barrel?
I believe, without having any scientific evidence, that it's the flame.
Actual flame.
Actual flame, yeah. That's what I think. This guy's not used to sleeping in the rain.
I got a question that involves these two guys in the middle here. Mr. Harn, if I'm going to come to you and I say, I want you to build me a custom gun, what kind of things do you want to find out from me? What kind of homework should I do before I come to you with that kind of a question? I'm a retired teacher.
He's got a problem. Let me stand here or anything back here. He said if you have a gun that fits you well, bring that. That's
Okay.
the start.
Takes measurements from the gun to.
I usually tell people to find a gun that they can close their eyes, put it up to their shoulder, open their eyes. If you're looking through the sights, that gun fits you. If it doesn't do that, then you need to do some sort of adjustment to get it.